So what do you notice when you look at these shear and bending moment diagrams? You notice that you need to draw a vertical line going down, and you're going to draw a line at every point is a change, right? You see that on your sheet, right? You don't have to draw it, I just want you to remember that. This is going to come down, this is going to come down. Anywhere there's something different. Is everybody comfortable on where you draw the lines? Line, 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 line.
And are these planes of shear?
No, we're just drawing lines. It's just graphical right now, there's nothing. Is everybody comfortable with how I'm dividing this beam up? Good? Okay, then we're going to draw our shear and bending moment diagram right below it. So I'm going to draw this is representing my beam, and here's my shear, the value that I get for shear. Positive, negative, 0. So I might have left out the V. Do I have a V on there?
Mm-hmm. Yeah.
Do I have an M for moment?
Yeah.
Do I have a plus and a minus and a 0? Okay, make sure you put the plus, minus, and 0 on all of them. Shear, 0, plus, minus. Moment, plus, minus, 0. Shear, 0, plus, minus. Moment, 0, plus, minus. This is how I start out every single problem. Shear plus minus 0. Moment 0 plus minus. What about units? Shouldn't we put units on it? So let's take a look. Here are, what's that? What's a K? 1,000 pounds. It's a kip. It's called kip, right? Kip, and we're looking at feet. So what's the unit of shear going to be? Kip. So we put units. And what's the unit of moment going to be? Kip foot.
Kip foot.
Foot pound. No, foot pound. Foot kip. Right? And then how about here? Again, we're doing foot and kips. This is kip, and this is foot kip.
I recognize kips as a validated pressure.
Actually, they're always, oh no, this one is pounds.
Two-step.
And this one is foot pound.
What? A two-step.
And this one is kilonewton. And this one is kilonewton meter. So you always do this. Tell me again what the numbers are that I circled in green. They're the reactions of the supports. Are they given? No. They just show you what kind of support it is, and then you have to calculate the reactions of each supports. Okay, you ready for the drawing now, the fun part? Okay, so take a look at this. We're going to look, we're going to do all the shear diagrams first. All the information you need is right up here on the beam. The beam shows the external forces that are supplied and the reactions at the supports that you calculated. Okay? So you always start and end at 0. At 0, Hughes, what happens to this beam right here at this point? What is it experiencing?
Tension.
Not tension, the number. What number is it experiencing? Right here at this point. What's it experiencing? 10 kips, no, right? And which direction is it? Up or down? Up. So I'm going to go up to 10 kips, and I'm going to stop. Mark, in here, between this point and this point, is it experiencing any forces?
Moment.
Forces. Is it experiencing any forces here? Right here it's experiencing 10 kips at this point, and at this point it's experiencing 10 kips. This one's up and this is down. But in here, is it experiencing anything?
No.
No, there's no external load, so it stays the same.
And Joanne, you started at the 0, right? Like
Right.
you start from 0 and go up to 10.
That's
You
correct.
Start at 10.
Right. You start at 0. Okay, Tara, what's happening now at this point on the beam? What's the load? 10 kips going down, so I'm going to draw 10 kips going down. And then Chris, what's going on in here?
Nothing. It's
Nothing,
just
so what's
left,
going to happen? It's going to stay the
you
same.
know.
Karen, what happens next?
Then it has a 10 kip going down.
Go down 10 kips. And do I have to write the units? No, because it's already written. Right, so I should just write 10. 10. What's next now, Eric?
No force.
No force, so stays the same. And then Wes, what happens at the end?
Goes back up.
Comes back up to 0, and then we color it in. And I didn't do a good job drawing this to scale, huh? So let's-
Yeah, you start at 0.
So what does this mean? Where is this beam experiencing a shear loading? We call this section 1, right here, section 2, and section 3. Where is it experiencing shear loading? So, what?
In section 2,
But section 2 is 0.
on the interface between 1 and 2 and 2 and 3.
Chris, where is it experiencing a shear loading? 1 and 3. Right? Because in this section, this beam is experiencing 10 kips of shear. In section 3, it's experiencing 10 kips of shear. But in between, it's experiencing no shear. Why? Because so Kyle, you're gonna help me. Here, well, Kyle, hold this end. Okay, JJ, you're gonna help me. Hold this end. So, and let's put your hands on the bottom so that it looks like it's a force going up. So right here, all within this first section, this beam is experiencing this 10 kips that are going up. It's not until it reaches here where there's a 10 up and 10 down that this part of the beam has the 10 kips canceling each other. So in this section, it is not experiencing any shear loading at all. In this section, at every point in here, this beam has to experience 10 going down to balance. But once I have the 10 balanced here, since 10 is balancing with 10, 10 is balancing with 10, there's no shear here. So if this beam fails in this section or this section, or rather, if this beam fails in this section, you can bet that it did not fail in shear. It probably failed in,
Support.
what's the other one? Bending. Peter.
What if we reduce those 10s to resultant forces? It seems kind of arbitrary that we have a cutoff 15 feet in and then 25 feet in.
Okay, so let's think of an application, right?
Yeah.
So we have this beam here, and it has 2 external loads.
Okay.
There's a 10 kip on it here and a 10 kip on it here. I don't know, picture something that's 10 kips. And then this beam was resting on 2 connections on the end. And when I did some of the moments and some of the forces, I found that each of these connections took 10 kips. So these were forces that were placed on the beam. These are the forces that we calculated as the reaction due to these external loads. And now we came up with what the shear diagram looks like.
Okay.
And now from the shear diagram, it is a visual, right? That's why we do these, they're visual. We know that within this section of the beam, this beam inside is experiencing 10 kips. So what would we have to design this beam for to withstand, to not fail in shear? More than 10, right? I have to choose a beam that could handle more than 10 kips. of shear, right? And if I wanted a factor of safety of 2, then it would be, I'd have to make sure that it handles 20 kips. Okay, but in the center, it's not handling anything. So let's do the next one. Okay, Jill, P. So I start at 0, what do I do now?
Go down 1.25.
Go down 1.25. Okay, next. Peter, what happens next?
Go up, sorry, just go straight across.
Same.
Yeah.
Then what? David,
Go up 3.75.
right, which is gonna bring me to what? 2.5, right?
Yeah.
Isadora?
Just go straight.
Stay the same. Okay. Evan's got the hard one. Now we're dealing with the distributed load. What do you think we should do? But let me ask you a question in parts. When the load goes down, what does the diagram do? Down. When the load goes up, what happens to the diagram? Up. So we know the distributed load is down, so we know it's going to go down.
Down.
But should it be a direct? So what do you think?
I think it should be over 5.
Over the 5 feet,
Yeah,
what should happen?
down 1.
Go down 1. So what should I, tell me how I should draw this?
It should go down to 1.5.
It should go down 1 foot, 1 kip per foot, and there's 5 feet. So I gotta go down how many feet? I mean, how many kips total?
2.
What's the area of a distributed load? You already know. You already know what force, right? The force is base times height. The base is 5, the height is 1, so the force is 5 kips. So I know I have to go down 5, but how should I go down? Should I go down here?
No.
What should I do?
In the middle.
Diagonal. Yeah.
Oh, the way it's supported.
Because it's going down 1 kip per foot. 1 kip per foot. 1 kip per foot. And Evan, if I went down 5, where am I right now?
2.5.
2.5. And then Armando, what do I do at the end?
Go back up.
Go up how much?
2.5.
Why?
Because you have the 2.5.
Because the 2.5 is here. And now let's color it in.